On October 10, 2023, a piston-engined fighter took off from Sywell Aerodrome in Northamptonshire, England, and flew for the first time in more than 50 years. Not the first time since its restoration, the first time since any Hawker Tempest of any variant had been airborne anywhere in the world. Half a century of silence, and then a Bristol Centaurus radial engine turning over at full power, an 18-cylinder, 2,590 horsepower engine that had been rebuilt specifically for this moment, pulling a fighter aircraft into English autumn air for the first time since the early 1970s. The aircraft is registered GTEMT. Its military serial number is MW763. It was built at Hawker's factory in Langley, Berkshire in 1945, accepted by the Royal Air Force, and never fired its guns in anger. The war ended before it reached the combat unit. It is, as of this recording, the only airworthy Hawker Tempest on the planet. Out of approximately 1,700 Tempests built across all variants, one flies. One. And the path that single aircraft traveled from a 1945 production line to a 2023 first flight after 34 years on the ground is a story about the gap between an aircraft's operational reputation and its survival rate, a gap wider in the Tempest case than almost any other Allied fighter of the Second World War. The Spitfire has dozens of airworthy examples worldwide. The Hurricane has a dozen. The P-51 Mustang has hundreds. These aircraft are celebrated, collected, restored, and flown. The Tempest, faster at low altitude than any of them, deadlier against V-1 flying bombs than anything the RAF put in the air, capable in a dive of matching early jet aircraft for sheer speed, has won. This is the story of that one aircraft and of why the Tempest almost disappeared entirely. The Hawker Tempest began as an attempt to fix a problem with one of the RAF's existing fighters, the Hawker Typhoon. The Typhoon had been designed as a high-altitude interceptor, but by 1941 it was becoming clear that the aircraft had a fundamental performance limitation. It was fast at low altitude, but deteriorated dramatically above 20,000 feet, where the thick wing section that gave it structural strength also created excessive drag that competitors exploited. For the role it was supposed to fill, high-altitude interception of German fighters and bombers, the Typhoon was underperforming. Sidney Cam, Hawker's chief designer, proposed a solution: retain the Typhoon's fuselage and power plant, but replace the wing entirely. The new wing would use a laminar flow profile, thinner, with the point of maximum thickness further back along the chord than conventional designs, which would dramatically reduce drag at speed and allow the aircraft to maintain performance at higher altitudes. The result diverged so significantly from the Typhoon that it was redesignated as a new aircraft entirely, the Tempest. The prototype flew in September 1942. What the test program revealed was not merely an improvement on the Typhoon, but something different in kind. The Tempest Mk5, powered by the Napier Sabre 24-cylinder H configuration engine producing 2,180 horsepower, became the fastest low-altitude fighter in the Royal Air Force. Faster than the Spitfire below 15,000 feet, faster than the Focke-Wulf 190 at the altitudes where much of the tactical air war over occupied Europe was actually fought. Against the Luftwaffe's best, it was formidable. Against the V-1 flying bomb, it was irreplaceable. From June 1944, when Germany began launching V-1s against London and southeastern England, the RAF needed an aircraft fast enough to catch the missiles, which cruised at approximately 400 miles per hour at low altitude. Most fighters couldn't match that speed at the altitudes where the V-1s flew. The Tempest could. It shot down more V-1 flying bombs than any other RAF aircraft type, 638 in total, out of 1,846 confirmed kills by all methods. More than a third of every V-1 that was shot down from the air was shot down by a Tempest. It then went to the continent after D-Day and flew ground attack missions against German transport, armor, and airfields. In the final months of the war, Tempest squadrons operating from forward bases in the Netherlands and Belgium encountered the Luftwaffe's jet aircraft, the Me-262, and proved capable of engaging them, particularly by intercepting the jets at their most vulnerable moments, on approach to land when their speed advantage narrowed. Tempest pilots were credited with shooting down a confirmed number of Me-262s in the final months of the war. At the end of the conflict, the Tempest stood as one of the genuinely exceptional fighters of the entire war. Fast, heavily armed, robust enough for the ground attack role, and proven against everything from cruise missiles to jet aircraft. And then, within a decade, it was almost entirely gone. The RAF flew the Tempest into the early 1950s, then retired the type in favor of jet aircraft. This was not surprising. Jet aviation made piston-engined fighters obsolete faster than any previous technological transition in aviation history. And the Tempest, despite being among the best piston fighters ever built, could not compete with the performance envelope of even early jet designs in a sustained engagement above 25,000 feet. What happened next determined why so few Tempests survived. When the RAF withdrew the Tempest from frontline service, significant numbers of Tempest Mark IIs, a variant powered by the Bristol Centaurus radio engine rather than the Napier Sabre, were transferred to newly independent India and Pakistan in 1947 and 1948. The Indian Air Force received 89 Tempest Mark IIs, and Pakistan received 24. Both nations operated the type until 1953, at which point the aircraft were retired and largely scrapped. Scrap was the fate of most surviving Tempests everywhere. Unlike the Spitfire, which had entered popular consciousness as the symbol of the Battle of Britain and attracted intense preservation interest from the moment the war ended, the Tempest had no equivalent cultural moment. It was exceptionally capable, it was not famous. The Typhoon and Tempest were aircraft of the middle and later war, ground attack aircraft, fast enough to survive the tactical environment of 1944 and 1945, but not associated in the public imagination with the existential survival narrative of 1940. Nobody had written songs about Tempest squadrons. No feature film had been made about V-1 interceptions over Kent. The aircraft that did the work of 1944 and 1945 were, for the most part, forgotten by the preservationists of 1946 and 1947. By the late 1970s, when serious warbird preservation interest in the Tempest finally emerged, the surviving population had been reduced to a handful of derelict airframes in varying states of deterioration. The famed warbird salvager Doug Arnold purchased half a dozen or so of the remaining Tempest IIs in various states of dereliction in the late 1970s and sent them all back to Britain. These aircraft became the seed stock for what would become, decades later, multiple restoration projects, including MW763. The engineering challenge those projects faced was specific and severe. The Tempest's Napier Sabre engine, the power plant of the Mk5 that had fought in the war, was one of the most complex and temperamental aircraft engines ever put into production service. 24 cylinders in an H configuration, sleeve valves rather than conventional poppet valves, enormous power output from a relatively compact installation. During the war, experienced ground crews had managed it. In the 21st century, the engineering expertise required to rebuild and operate a Sabre had effectively disappeared. No Sabre-powered Tempest had a realistic path to airworthiness. MW763, powered by the Bristol Centaurus rather than the Sabre, offered a more tractable engineering problem. The Centaurus, while complex, was a more conventional radial design with better documented maintenance procedures and surviving engineering knowledge. It was the Centaurus that made MW763's eventual restoration possible. MW763's restoration history is, in its timeline, one of the most extended warbird projects ever completed. The aircraft was built in 1945, accepted by the RAF, and transferred to the Indian Air Force in 1949, where it served with the serial HA-586. In 1989, it was transferred to Brooklands in Surrey with Autocraft Ltd. With a new civil registration GETEMT. That 1989 date is when the 34-year clock starts. From the moment GETEMT received its British civil registration to the moment Pete Kinsey flew it from Sywell on October 10, 2023, 34 years, during which a single airframe passed through multiple ownerships, multiple facilities, and multiple stages of restoration work that never quite reached completion. The aircraft spent time in Wickenby in Lincolnshire from 1997, still under the ownership of Tempest 2 Limited. It moved to Dunmow in Essex in 2016 when Anglia Aircraft Restorations Ltd. took over the project, and it moved to air leasing at Sywell Aerodrome in Northampton for its final stages of restoration before the 2023 flight. 3 locations, 3 organizations, 34 years. This pattern, the long, interrupted, owner-changing, facility-changing restoration timeline, is characteristic of rare warbird projects where the aircraft's complexity exceeds the resources of any single organization, and where the part supply problem is not merely difficult, but in some cases involves components that have never been commercially available since the aircraft's production ended in the late 1940s. The Bristol Centaurus engine that powers MW763 was not merely cleaned and reassembled. It was sent to North Wales Heritage Aviation in Epping to be rebuilt. This is a specialist facility, one of very few places in the world with the knowledge and tooling to work on Centaurus engines at an airworthy standard. The rebuild of a single aircraft engine for a warbird restoration can take years and cost more than the market value of many complete airworthy aircraft. The airframe itself required structural work that went beyond cosmetic restoration. An aircraft that had sat in varying states of storage and partial disassembly for decades accumulates a category of deterioration distinct from active corrosion or storm damage. The slow degradation of sealants, the stress relief of structural fasteners left in place for decades, the dimensional changes in aluminum components that have experienced countless thermal cycles without the stress relief of operational flight loads. Each discovery leads to another assessment, another repair decision, another entry in a maintenance log that by the project's end had grown to encompass decades of incremental progress. On October 10, 2023, pilot Pete Kinsey flew the freshly restored MW763 on its maiden rebuild flight from Sywell, the first time a Tempest of any mark had flown in more than half a century. 50 years of silence ended by one engine starting, one aircraft rolling down one runway, and one pilot lifting the gear handle for the first time. The restoration of a rare warbird to airworthy standard is not a transaction that lends itself to simple accounting. The 34 years of work on MW763 involved volunteer hours from specialists whose expertise cannot be priced at standard labor rates, donations from individuals and organizations who understood what they were funding, and the accumulated value of engineering knowledge that exists in very few places worldwide. But it is possible to understand the scale of what this kind of project requires by examining what it involves. The airframe assessment alone, the systematic inspection of every structural component to determine what can be preserved, what must be repaired, and what must be fabricated new, requires skills that combine aviation engineering, metallurgy, and the specific historical knowledge of what the original design intent was for every component. For an aircraft type as rare as the Tempest Mk2, the reference material for this assessment is itself scarce. Original Hawker design drawings survive in archives, but are not always complete. Period maintenance manuals exist, but describe procedures for ground crews working on operational aircraft, not restoration specialists working to airworthy standards under 21st century regulatory frameworks. The fabric-covered control surfaces, the ailerons, elevators, and rudder, require replacement on any aircraft that has sat for decades without flight. The specific fabric, the specific doping compounds, the specific attachment methods all require expertise that belongs to a shrinking community of specialists. When a control surface goes wrong, you do not order a replacement from a manufacturer, you build one. The hydraulic and pneumatic systems of a 1940s British fighter were designed for ground crews working on operational aircraft, replenishing hydraulic fluid from standard military depots, using tools and fittings that were common across the RAF's inventory. In 2023, sourcing replacement seals and fittings for systems designed in the early 1940s involves a supply chain that ranges from specialist aviation part suppliers to industrial seal manufacturers who may not know their products are going into a WW2 fighter. Every one of these challenges was solved, over 34 years, by the people who worked on MW763. The aircraft that flew on October 10, 2023, represents not a single restoration achievement, but the accumulated solution to hundreds of individual engineering problems, each one requiring judgment, expertise, and in many cases, improvisation within the constraints of airworthiness regulations. There is currently another Tempest Mk2 under restoration in Canada, MW376, being restored by KF Aerospace in Kelowna, British Columbia. When that aircraft flies, there will be 2 airworthy Tempests in the world. That will be the largest number of airworthy Tempests that have existed simultaneously since the type was retired from operational service. 2 aircraft out of approximately 1,700 built. The Hawker Tempest's near disappearance from the surviving warbird population is not simply a story about institutional neglect or inadequate funding, though both played a role. It is a story about how the survival of historic aircraft depends on cultural attention as much as physical preservation, and how aircraft that don't receive that attention in the critical years immediately after retirement tend not to survive. The window for warbird preservation is narrower than it appears. An aircraft that sits outdoors for 5 years is damaged. An aircraft that sits outdoors for 10 years is severely damaged. An aircraft that is scrapped is gone. The decisions that determine whether historic aircraft survive are made not by museums and preservation organizations acting with considered judgment, but by military accountants, scrap metal contractors, and storage facility managers operating under their own constraints and timelines in the years immediately after a type is retired. The Spitfire survived that window in large numbers because of its iconic status, because the Battle of Britain narrative had already established it as a symbol of national significance before it was retired. Spitfires were preserved by individuals, by squadrons, by museums, by governments, before anyone had to make a deliberate case for their historical value. Their value was assumed. The Tempest's value was not assumed. It had to be argued. And by the time the argument had been made convincingly enough to motivate organized preservation efforts, by the time warbird collectors and aviation museums had developed both the interest and the resources to pursue derelict Tempests in India, Pakistan, and Britain, most of the original population was already gone. What survived did so largely through accident. MW763 survived because the sequence of owners and facilities that held it over 34 years never quite let the project die, even when progress stalled for years at a time. The aircraft that are now under restoration in Texas and Florida survived because collectors with the resources and commitment to acquire them did so before the remaining airframes deteriorated past the point of recovery. The Tempest Mk5, the variant that actually fought in the war, powered by the Napier Sabre engine, is represented by 2 surviving airframes currently being restored, neither of them yet airworthy. There are 9 complete Tempest Mk9s and just 2 Mk5s extant. The Sabre engine's complexity means that even when those airframes are structurally complete, the path to an airworthy Sabre-powered Tempest V involves an engineering challenge that has not yet been fully solved. It is entirely possible that no Tempest Mk5 will ever fly again. On the morning of October 10, 2023, Pete Kinsey lined up MW763 at Saiwo Aerodrome and advanced the throttle. The Bristol Centaurus, 18 cylinders, 2,590 horsepower, rebuilt at North Weald, turned the 4-bladed de Havilland propeller at full power. The aircraft that had not left the ground in 5 decades began to roll. The tail came up. The main gear lifted. The only airworthy Hawker Tempest in the world climbed away from an English airfield in autumn morning light. There is a practical argument for why this matters, why a 34-year restoration project involving an aircraft that saw no actual combat is worth the engineering effort and financial resources it consumed. The practical argument is that airworthy historic aircraft are the most effective educational instruments that exist for conveying what these machines actually were. Film and photography and scale models describe aircraft from the outside. Flying them describes them from the inside. The engine sound, the control forces, the visibility patterns, the physical experience of what it was to sit in this cockpit and operate this system over the English countryside in 1944. But the more honest answer is simpler. The Tempest shot down 638 V-1 flying bombs. It flew ground attack missions that cut German supply lines in the final year of the war. It engaged jet aircraft that had no right to be matched by a piston-engine fighter, and it matched them. It was, by every technical measure, among the finest fighters the Second World War produced. And because it was not the Spitfire, because it did not have a 1940 moment, because its excellence was the workaday excellence of a wartime aircraft doing difficult work in difficult conditions without the mythology that attaches to survival stories. MW-763 flies. That is not nothing. In a world where the aircraft it represents almost ceased to exist at all, the fact that one example, one out of approximately 1,700 built, can still be started, taxied, and flown is the difference between a type that lives in documents and photographs and a type that lives in the air. And living in the air, however briefly and however rarely, is what these aircraft were built for.